Good afternoon. It's an honor for me to be with you today, and I would like to thank the organizers for inviting me to share our observations and thoughts around opportunities and challenges for healthcare AI, and with a particular view to impact of AI on society. In a virtual conference, in this day and age, you might expect my digital twin to be giving the presentation, but unfortunately it was not feeling well today. So it will be my pleasure to walk you through the need for AI in healthcare, the opportunity that it presents, the barriers to adoption that we're all facing, and a little bit on COVID-19 and its relation to AI. Let me start with the problem that we're trying to address and solve. It is very meaningful. It's a very important purpose for us to think around all of the patients around the world that are suffering from chronic diseases. We are very well aware that healthcare systems around the world are under pressure to deliver better care, to reach more people, and to do that in a more cost-efficient way. It is clear that people are ambitious to take more control over their own health, their own well-being. And at the same time, the digital transformation is creating an enormous amount of data that no single person alone can digest. What does it mean in numbers? In numbers, it means that 1 out of 3 people will be diagnosed with cancer in their lifetime. It means that about 400 people worldwide are suffering from diabetes. 1 billion adults having hypertension, and even before COVID, more than 500 million people suffering from respiratory diseases. In short, the silver tsunami of people like myself are putting enormous burden on the healthcare system. And indeed, if we look at it, there is a huge cost increase for taking good care of us all that societies need to pay. Patients and societies increasingly demand better outcomes at lower cost. But what is much more important is that there is a significant amount of burnout amongst the care providers, and we cannot even educate care providers fast enough to take care of the growing needs of all of us on this planet. There's literally billions of skilled healthcare professionals which will be missing, which are not there when we need them. So the problem is, how can we provide adequate, good, state-of-the-art care and improve the way in which we empower people to deliver this care? This is the need, and it is our passion that we want to contribute in this space. On the other hand, we have a plethora of data on health, which is being accumulated year in, year out. It is not just the health tracking devices. It is also the medical imaging equipment. It is the patient monitors. It is monitoring in the home, with care being progressively shifted out of hospital settings to home settings. It is medication adherence devices. It is the amount of data that pathology and genomics provide. In a recent study that Stanford published, there was an explosion from 153 exabytes of health data in 2013 to 2,000 exabytes in 2020 expected this year. For those of us not quite as familiar with it, 1 exabyte is 1 million terabytes. Think of it another way. There are 300 million hard disks still being shipped year in, year out. If one hard disk has about 10 terabytes, you're seeing that about 3,000 exabytes are being shipped as new storage, and a large amount of that is being actually taken up by healthcare data. So perhaps between 300 million terabytes and 3,000 million terabytes. It's an enormous amount of data. No single team, no single collaboration, no single network can find all of the patterns in there and can harvest that to bring up and to educate our way of dealing with healthcare. What do we need? The data alone is a vast amount of unharvested insights, but we need artificial intelligence to make sense out of that. We define it loosely as artificial intelligence as being data science techniques designed and created by people, inspired by intelligent behavior to create systems and solutions that can make a difference in the real world. Actually, in detail, we adopt the definition of the European high-level experts group on AI, but we've tried to get the essence into this little statement. It's about people who define the purpose. It's about people who design how to get to that purpose, how they make sense out of it, and to then make an impact. As I was saying, data alone is only one element. Artificial intelligence is only the second element. It can help us see patterns in vast amounts of data that our single brain cannot make sense of. But we need close collaborations with clinical partners, with clinicians in our own teams to hypothesize out of those correlations that we see, to create work mechanism hypotheses that we can say, okay, if we change this element, it will have that consequence, to then validate those things in clinical practice, to then roll it out. You see that we need to bring together these three elements: the trove of data, the artificial intelligence tools, and the deep clinical knowledge to be able to create solutions that actually empower people, that adapt to the context, and that integrate into the workflows to make a difference. Unfortunately, this is going slightly too fast. The purpose I was saying before, mentioning, can be captured in something that is called the quadruple aim. It extends the triple aim that has been around for some years, which consisted of striving for better health outcomes for the individual patient, lowering the cost of care, and thus enabling better access to care for whole societies, improved patient experience while going through the healthcare system. And the fourth element that is added, going from the triple aim to the quadruple aim, is to recognize that we need to take care of the staff at the same time, to recognize their workload, their burden, and to try to alleviate that. So our North Star is actually to use the data, to use the AI technology, and together with clinicians to create solutions which are serving these four aims. It's our North Star. How does that really translate into actionable concepts, into products and solutions? For once in this presentation, I will take an example from our own solutions, and I apologize for the fine print. It's essentially a software that is designed to detect deterioration conditions of patients on the general ward. You will all be familiar with the fact that patients are under a very close observation network while they're in intensive care. When they progress to better health, they are discharged onto the general ward, but there are mainly spot check measurements, general rounds, and other ways of dealing with detecting the patient's care when he or she does not flag a difference in itself. What we've used is data science and AI on patient data, on monitoring data, combining it with other elements from the patient's record. And what you can then see is astonishing. It was surprising to us until we actually did the study. It's not just a workflow improvement. This is actually helping outcomes. You see on the bottom right, the two elements that I have circled in red. Patients, when they need to go back to the ICU, unfortunately sometimes die. But for the patients with this solution that were sent back, the mortality rate was reduced by 2/3. And that was not at the cost of sending everybody back to the ICU, as some of the other figures show. But what was even more important to us was that the cardiopulmonary arrest rate for the patients on the general ward was reduced by a whopping 5/6. Essentially, what you see here is that a solution like that can anticipate from the early signs the things that may happen to a patient, is an extremely valuable safeguard. It improves, I would argue, in the North Star axis that we had before, the outcome. It improves the patient experience. It improves the care provider experience in knowing when to care for which patient. And it actually also allows us to take care of more patients. This was shown in a retrospective study, in a comparative before and after study, before and after introducing the solution. So it's actually meaningful to see that some of these solutions are actually making it to the patient care and are not just abstract concepts, but can really be translated into things that deliver on some of our promises. However, if you look back 2 or 3 years ago, there were some very optimistic comments that said we should stop training radiologists because they will no longer be needed in 10 years. Those quotes have been walked back significantly because we're seeing a handful of well-proven devices make it to clinical care, but we're not seeing the radiologists or the clinicians being totally replaced. There are significant barriers, and if you want to see more on it, there's a wonderful chapter in an EIT, which is a body of the EU document on transforming with healthcare, a whole chapter which looks at barriers and ways to overcome them. For the purpose of today, I wanted to speak to 6 of them and give you examples and underpinning for 2 of them. The technical performance. We're seeing more and more cases where there's a very good comparison between the technical performance of an algorithm versus the human equivalent performance on simple, well-defined tasks, well delineated. So artificial generalized intelligence is still way out, but the intelligence that helps us make sense out of a plethora of data right now, in some cases, is reaching human equivalent or sometimes even surpassing it in well-defined cases with well-orchestrated studies. I'll give you an example in a moment. Together with that documentation of the technical performance and the potential clinical impact, the trust and the trustworthiness in these algorithms has gained much traction, and so I would rank that as a yellow currently. Regulatory approvals, which were a concern perhaps a year or 2 ago, we're actually seeing that for locked AI, regulatory approvals are not an issue. They require additional work perhaps, but there are several pathways. If you look at the FDA, for example, the 510K pathway, which allows you to approve, to submit for approval a device based on the comparison with the predicate device, showing substantial equivalence, is very well appropriate and very sufficient for these devices. There's pre-market approval for novel devices, and the FDA has even created an additional pathway, de novo, for applications which have a huge potential benefit and which have no predicate device because they're so new. In essence, what I'm saying is that if you have locked AI, where you have a training, you freeze the result, you validate it on the appropriate cohorts, which are in relation to the intended use of your product. There are sufficient methods for getting it through regulatory approval, and the oversight is actually appropriate there. Privacy and ethics has been mentioned before also. And so for us, the privacy rules that are in place, they're a given. We work inside and we are still able to do scientific research and we're still able to do product development. It requires attention, which is why, as I'll show you in a second, we have given ourselves privacy and ethics principles in the AI space to adhere to. But within that, when you're doing things to really help people through their lives, to save their lives, we think we have a good case to make. What we're struggling with as an industry, in partnership with our clinical customers, is the deployment cost. There is anecdotal evidence that even a single well-proven example requires significant person months for integrating, not just into the IT systems of the clinic, but also into the clinical workflow with all of the changes that it induces. This is a huge cost, and it does not scale well if you need to have hundreds of different AI solutions. Finally, the return on investment is an actual concern in the sense that our customers need to make money on the solutions that we deliver to them. They need to get their investment paid back, and that can be one of 2 ways. It can be improving workflow so that they can actually tend to more patients at the same time with the same effort, or it can be statutory reimbursement if there is better quality that we can show. Both things are a bit difficult. For the workflow improvement, it behooves us to show together with them that the workflow improvement is actually there, that the AI is not actually slowing down the clinical care. And it is even more difficult when you talk about statutory reimbursement and similar compensation mechanisms, which require health economic studies where we don't have enough in the space. So overall, I think some of the expected culprits are not really keeping us back, and it's actually more in scaling it out in an industrialized fashion that we are hitting road bumps. I apologize for showing a technical slide. This is from a recent publication in Nature, and it essentially shows on the vertical axis the sensitivity. So if you have a number of people in your population that have a particular condition, how many of them are you correctly picking up? On the horizontal axis, you see how many people that don't have a condition are inappropriately classified. This is a very nice example where a study actually compared eye to eye between the human and the AI tool. The green dot shows the human reader in a particular screening scenario. You see that the curve is to the left and to the top of that, which means that the AI is actually in this particular question outperforming the first human reader. What is important to note is the blue box, which shows the second reader, because in this particular country, there is a consensus reading. A first reader reads it, the second reader reads it again with the knowledge of what the first reader had. And if they disagree, they actually do an arbitration, which is the red diamond. Now, if you see that the red diamond is about as far left and above the curve as the curve is above the first reader, the conclusion that also the authors here came to is the solution is actually better than a single human, and it's actually not as good as the standard of care. They then go into arguing whether it is appropriate to use it as a second reader, but I would actually advance that you've just proven that it is better than the first reader. Substitute it for the first reader, then have the second reader look at it, and then we will have an improvement in the standard of care. And these sort of studies show where the strengths of these solutions are. They show where you need to integrate them appropriately into clinical care. And there's an opportunity here. I wanted to use it as one example of where things are moving in the right direction with trustworthy solutions that are robust and proven. I mentioned earlier that our data principles and our AI principles are important to us. So we looked very closely at the recommendations of the EU high-level experts group, and we've distilled out 3 in the data domain and 5 principles for us in the AI domain. It's the health and well-being of patients and populations that we need to advance. It is under human oversight. We're not replacing, but we're augmenting. It is with robustness that we need to validate. We are committed to fairness, to avoiding bias and discrimination. And we've committed to transparency, which I show you on the next slide. On a web page that we've put up in public, we say which of our offerings have AI inside, what the AI functionality is, and how we validated it in an attempt to be transparent to create trust. We cannot always explain and rationalize in a general public understandable fashion, but we have scientific publications, dozens, scores of them, which are also there to underpin it with more detail. I would quickly talk about COVID and the AI relationship there. So when COVID hit, what Phillips tried to do was ramp up critical healthcare technology from ventilators, bringing out a new ventilator, from increasing the speed with which we can refurbish CT machines, all of that very successful in scaling up and trying to address the shortage that was suddenly there. We have created pre-hospital screening surveys that allow healthcare providers to keep patients monitored at home before needing to bring them in for consultation. We have worked in the Netherlands to create a national portal for hospital exchange of data so that patients moving their data move with them between the hospitals. There is a question about the value of imaging in this case, which I would like to highlight on the next and almost final slide. And that is the different geographies, the different societies came with slightly different approaches to whether you should be using the standard PCR test or whether you should be using imaging first. If you used imaging first, as in China, or in particular guidelines recommendations, there is, of course, a role for triaging and staging. This particular case here shows when you've got a COVID suspect patient, in one case, you don't have access in a timely fashion to the gold standard truth, then imaging is helpful for triaging. In the other case, you do know that the patient is there, and so you needed to stage appropriately and to see how the patient will progress. Not all of the societies were for this, and not all of them sort of provided the inroads. We believe that there is a reason to use AI in this space to alleviate the burden in the hotspots, and we've worked on some of the solutions in that space. In conclusion, what I've tried to bring across is that we understand that AI represents a dramatic opportunity. We've not been disappointed, but on the contrary, we see individual solutions maturing to the point of being proven enough to be able to be used in standard of care to integrate into the clinical workflow. There are many point solutions. There are dozens that have been approved by the regulatory authorities, but it behooves us as manufacturers to now make it easier to integrate them, to put them into consistent day-to-day use without person months of effort upfront. And finally, we have given ourselves the data and AI principles to transparently share where we are working and why we are working on this, to try to understand, to try to create the transparency and trust which we owe society. With that, I would like to thank you for your attention, and I would like to open it up for questions. And please post your questions in the chat so that they can be shared with me.
Thank you very much, Hans-Aloys. It was a fascinating presentation. I mean, AI has so many facets, and I think you touched upon several of them. We have already quite a number of questions that came in during your presentation, and some probably were particular at the point that you were showing a slide. So I'll see if I can kind of get these questions in the right order. The first one was about when you talked about the various barriers. Do you really believe that people will accept AI when the barriers that you discussed are resolved? And if there is a question, what do we have to do to enhance acceptance even more?
So I believe that in healthcare, there is a need for trust, there is a need for transparency, there is a need for being able to get a return on investment so that you can actually pay the people to take care of the patients. I believe that in combination with humans, AI will be adopted almost across the board wherever it is proven to be on par or superior to humans. We will not accept that the doctor looks at a computer screen and says, the computer thinks you've got a flu. We will still want that personal interaction, but the doctors, as far as we see, appreciate safety nets. Indeed, in some geographies, even during COVID, we've seen individual networks of imaging centers reading 3,000 to 5,000 CT image data sets a day, and doing that in a fashion where the AI looked at it first and the radiologist looked at it second to make sure that they could deal A, with the workload, and B, have that safety net in the background. So we see the adoption once it is proven, and it behooves us on the science side to underpin it with rock solid performance information. And we need to go together with our clinicians to show the clinical benefit and clinical impact. If we do that, and if we're transparent and create the trust via those paths, I'm convinced that it will take off, perhaps not as quickly as expected 3 years ago, but in a very solid fashion over the next 2 or 3 years.
So clearly you don't take the human out of the equation. That's at least not yet, that's for sure. So does it mean that you see these systems more as kind of decision support solutions for people?
We see them following the FDA classification. They can help for triaging to know which patient to treat first or to look at first. They can help for detecting things and pulling and making the radiologist or human aware of it. And they can progressively help in diagnosing. That's a sequence of steps, and you need more and more evidence the further you go. We currently do not think we are ready to take the human out of the loop, but we are gradually seeing that in some cases the human isn't actually adding value, and so there it will gradually be the case that the role will be more a supervisory mode, looking back retrospectively at cohorts and the performance, monitoring it, overseeing it in some sense. But that is in very delimited cases where the proof is excellent. For some time, the human will stay in the loop. But when we're actually freeing them up, it's the more differential tasks, it's the more higher value add tasks that we're freeing them up to focus on.
We got a question with this time a name with it, which is interesting. I think we now have kind of a perspective of who's asking the question, and that is, Mr. Wishmann, what is the most valuable lesson that you've learned from COVID-19? And it was Dennis Wissenberg who asked this question.
The most valuable lesson is you can accelerate if you focus, and then you don't need to cut corners. So we've been able to put things through normal regulatory approval in a totally different timeline by changing the way that we work and changing the focus that we have. There's always a tendency to want to do everything and to sort of explore all of the AI possibilities, but focusing and still doing the rigor and still getting it done right without cutting corners is something that the COVID epidemic or pandemic has taught us, that is in us, and it has brought it out.
The answer to the previous question about enhanced systems sparked another question, and that's regarding the transparency of AI. I mean, the person that asked this question said many AI algorithms are black boxes, neural networks. How would you explain how the AI works for the public, even if it's even for developers hard to understand sometimes which mechanisms are being identified?
So we've needed to go a dual approach here. What we commit to the general public is that we say where there is AI inside and how we validated it. We also cannot explain to the general public how a CT reconstruction works in looking at individual projection images and calculating back with a filtered back projection or other methods to get the individual voxel images. That is something that we document in the scientific papers, where we use visualization, where we use some other tools to sort of probe whether the algorithm is working actually as expected. So we do both. We do the scientific publication for the expert audience to challenge us on the approaches, and we do a public information about the general principles and how we ensure that it is working as intended.
I also actually assume that if the public sees the benefits of AI in healthcare, that also the acceptance will come, right?
The acceptance will come, but we owe it to society to be as transparent as we can. As you mentioned, we cannot always explain it. We can rationalize it according to the model that we've built, the architecture of the model, the training data, the validation data. Those are for the scientific audiences. And at the same time, we owe a transparency to when is there AI inside and how did we check that it works as intended. That's what we owe society, I think.
I mean, you have challenges convincing the general public, but on the other hand, what are the most common challenges that you face when productionalizing AI algorithms in order to fit them into clinical workflow?
There's two challenges. One is to ensure that you're broad enough in your validation data set that you cover the intended use cohort. And the second is it's not the IT integration. It is the change of the paradigm. So you can go either for a primary reading via AI, you can go for a concurrent reading to check whether the doctor agrees, or you can go for a secondary reading to check afterwards whether the AI would agree. All three of them have impact on the clinical workflow. In one case, there's already additional information available, and the clinicians need to make use of that and to be comfortable with it. In the second case, it's almost like somebody looking over their shoulder, which has an impact on the way work is organized. And the third case is next morning you get, hey doc, you want to look again at this particular image from yesterday, which is also perhaps not a comfortable thing. So we need to make sure that we actually improve their work experience and the work results. And that is a difficult thing to prove.
Now, there's an interesting question from another viewer is, how actually do you deal with machine-made type 2 error?
So I hear that we unfortunately out of time. I'd be happy to take additional questions. You know where to reach me, and I'd be very much interested in engaging with the team that is on the call today. It's been a pleasure with all of you.
Okay, thank you very much, Hans-Aloys. I really appreciate you being with us here in Rotterdam through this online summit, and I hope to see you soon.